Now we will study the monotonic technology. First, what is monotonic technology? We should know about this. Monotonic technology generally refers to different input vectors that produce the output. Okay. Now there is a possibility to produce one unit of output from different combinations of inputs. Suppose we write 6, comma 4. Now 6 are the units of labor that are used in the production process and 4 are the units of capital used in the production process at a particular time. So we can say that X is a feasible way to produce Y units of output. That is, this combination X is a feasible way to produce Y units of output, and therefore we can also say that x prime is an input vector. Then we will give this a name of x prime. That is, the x prime is an input vector which is used to produce the y units of output given the combination of 6 units of labor and 4 units of capital. So therefore we have different input vectors that produce the output level. Their combination can be changed. We can change this combination level, that is, it can be 6-4, it can be 2-4 to produce the output at any given time. So we can say that X is a feasible way to produce Y units of outputs, okay? X is a feasible way to produce Y units of output, and X prime. Now this X prime is the input vector that is utilized to produce the Y units of output. Therefore, inputs are required to be monotonic to produce the output. Now there are three different factor combinations which are shown in the figure, that is the figure is named as figure 2.2. The first one is somewhat like this, where over on y-axis we have factor 1, on x-axis we have factor 2. Now one combination of factor 1 and factor 2 is yielding the output in this way, okay, clear? The second one is the factor combination has been changed, and therefore the output curve is somewhat like this. It is showing that different combinations of factors can be utilized in order to produce the given level of output, that is y. And now this one is a bit like this. So these are three different output curves showing us the output level by changing the factor combinations. One over here shows the factor 1 and 2 shows the factor 2. Basically 1 and 2 we have denoted labor and capital with 1 and 2 because they are the most common forms of factors of production. Now in these figures we assume that y is in y, that is, small y lies in the capital Y. Capital Y is the level of output that is produced, and therefore capital Y is smaller than small y. Now these are the production functions, okay. Now we have assumed that small y is in capital Y, that is, it is small y due to which this capital Y is produced, therefore capital Y is less than small y. Now therefore the output vector, that is small y prime, it should also be in small y. Okay, you should be able to differentiate between small y and capital Y. Therefore, if y prime is less than, therefore if y prime, the small y prime is less than small y, smaller y, okay, then every component of vector y prime is less than or equal to the corresponding component of y. If this output vector is less than the output level y, then what happens is that every component of the output vector, that is y prime, it is less than or equal to the corresponding component of y. Now the production plan, which is represented by this y prime, okay, it produces equal or smaller amounts of all output by using at least as much as all inputs as compared to y. This is the basic interpretation of this term. I'll repeat it again. Now the production plan represented by y prime produces an equal or smaller amount of all the output by using at least as much of all input as compared to y. Hence, it is natural to assume that if y is feasible, if y this is feasible region, or you can say that if this y lies in the feasible region, then this y prime must also be feasible. After this, we have now we can see that the curves over here, they are not convex, but whenever we are concerned with the production function, we study a concept or a term which is known as isocon curve, which is convex to origin. Now we will move from monotonic technology to convex technology. What is the convexity of any function? Convexity of any function shows that the curve should be in this way, that is, if the factor 1 has to be increased, then factor 2 has to be increased, and if factor 1 has to be decreased, then factor 2 has to be increased. So now we move from monotonic technology to convex technology. What is convex technology? In the convexity of technology, we need to assume an actual output of commodity. Now we have moved towards the actual output of commodity. Suppose we produce 100 units of any commodity. Now we have a commodity Q. Okay. Now we want to produce 100 units of this commodity. Okay. If we multiply the vectors 1, 2 and 2, 1 by 100, now we have two input vectors. Okay. One input vector is 1, comma 2, okay, and the other input vector is 2, comma 1, okay. Now if we multiply these vectors by 100, okay, this one as well as this one by 100, we will get the following identity. Which identity? At this point we should be able to replicate what we were doing before and produce 100 times as much more. Of course, by multiplying these input vectors by 100, we get the replicate function, that is, we will produce 100 times as much. In any possible situation, production processes will necessarily allow for replication. Now suppose we have multiplied them by 100, then our input vectors will become 100, comma 200, and in the same way for the other one we will have 200 and 100. So therefore, in this process of replication, we can explain that 100, 200 and 200, 100 are the vectors of 100. Okay. Why are they vectors of 100? Because we have multiplied both of them with 100, which both values 1, 2 and 2, 1. Okay, suppose we operate 50 processes of activity A and 50 processes of activity B. Now what we are doing, we are processing 50, we are operating 50 processes of activity A and of course 50 processes of activity B. What will happen is that and then we will use 10 units of good 1 and 150 units of good 2 to produce 100 units of outputs. How will this happen? Now what we have done is that now we have operated 50 units, okay, 50 processes of activity A, okay. Now this will now become 10 units of good 1, okay, and 150 units of good 2 to produce 100 units of output. Hence, therefore, now what we should have? We should have 150, 100 should be the input requirement set. Therefore, now our requirement set will change. It will not be as given in the above input requirements. Rather, it will become 150, comma 100. That is 150 and 100 is now the new input requirement. Now we move on towards the convexity. In the convexity of technology, if x and x prime are in Vy, now we have two input vectors. One is x and the other one is x prime. Okay, they are in the production set, that is Vy. Okay, then tx plus 1. Then what will happen is that we will have a new equation, that is t x plus 1 okay, plus bracket 1 minus t x prime. These are different input vectors, okay, one is x, the other one is x prime. Now it will then lie in the Vy if and only if and only if 0 is less than t and t is less than 1. That is Vy is the convex set. Now this Vy will be this production set will be convex set if the value of t is greater than 0 and the value of t is less than 1. That is, if we have 1 minus t over here, this value should be less than 1 and therefore some positive number should come over here. And of course the value of t is greater than 0 also means that some positive number should come over here. If this is the requirement over here, then we will have the production set Vy, which should be a convex set. That is, our convex set would be like this. We have y over here and x over here on x-axis. Now let's study it again in a bit explanatory form. If a large amount of good is produced by a single firm, okay, a large amount of good is produced by a single firm, then we can replicate small production processes. Technology should be modeled as being convex, which increases with each increase in the production. Now, if a firm produces large amount of goods, then what happens is that the firm can replicate small production processes in order to show the in order to produce the large amount of goods. Now, technology will be convex, which increases with increase in production. Now what happens is that as the level of as the production level increases, the technology will also increase. If the scale of underlying activities is large relative to the desired amount of output, convexity may not be a reasonable hypothesis. Now there is another condition or statement which is leading us towards another point, that is, if the scale of the activities is large, okay, relative to the desired amount of goods, that is relative to this amount of good that is the firm is producing, then what will happen is that then this convexity condition may not hold. If one vector of input x produces y units of output, then we might use other vector that is x which also produce y units of output. What is it saying? If one vector of input x, it produces the y units of output y, okay, then we might use another vector that is x, okay, then there might be another vector that is x which also produces the y units of output, okay. Here we might use x for half the amount and x prime, okay, for the complete amount. One is used for half the amount, the other one is used for full amount. Now this is the convexity concept or term. Now we will move on towards another term that is regular technology, and after that we will move towards Cobb-Douglas technology. Now what is regular technology? Now few production functions require regular technology to produce output. Sometimes it may be difficult to adjust output with new technology. Okay. What happens is that sometimes we use regular technology in order to produce the output, and because it is difficult to adjust to some new technology. In the regular technology set, the weak regularity condition concerning Vy is explained as regular technology. That is, when we are concerned with regular technology, we are not incorporating new technology in our production set because maybe it is difficult to adjust to that innovative or new form of technology. Therefore, what we do is that we use the regularity condition concerning the production or production set Vy. Vy is closed non-empty set for all y greater than equal to 0. Okay. What is this Vy showing? It is saying that all the values of y are either greater than or equal to 0. It cannot be a negative number. It is assumed that Vy is a non-empty set, okay, which requires that there be some conceivable way to produce any given level of output. Suppose we have a sequence x1 of input bundles, okay, we have a sequence that is x1 of input bundles that is producing some level of output y. This sequence converges to an input bundle x naught. That is, the sequence, if it has started from x1, it will at some point of time converge to the input bundle x naught. We can say that the input bundle in the sequence gets arbitrarily close to x naught. By converging of x1 to x naught means that it will come very closer to this bundle, that is x naught. Suppose Vy is a closed set, then this limit bundle x naught must be capable of producing y. If this is a closed set, that is, if Vy is a closed set, then x naught should be sufficient to produce the y units of output. This means that the input requirement set must include its own boundary. Therefore, this is sometimes also true in the production set. Now our topic has completed over here. We will start with our new topic after this one, and that is the Cobb-Douglas technology and Leontief technology. Thank you for being a part of this lecture till here. If there is any question, you can ask me. Thank you.